Welcome back. In this video, we're going to study pyramids and cones. These solids are different from prisms and cylinders because they do not keep the same width all the way up. Instead, they narrow to a point. Because of that, their volume is smaller than the corresponding prism or cylinder with the same base and height. A key fact is this. The volume of a pyramid is 1/3 the volume of the corresponding prism. That means if a prism and pyramid have the same base area and the same height, then the pyramid holds exactly 1/3 as much. So the volume for a pyramid is 1/3 base times height, where base means the area of the base. The same idea works for cones too. A cone is 1/3 of the corresponding cylinder. This 1/3 relationship is very important, and it's worth helping students understand with models if possible. If students only memorize the formula, they may forget it. But if they know the pyramid is a smaller, pointed version of the prism, the factor of 1/3 feels more meaningful. Let's begin with a triangular pyramid. Let's suppose we are told that the base is a right triangle, and its side lengths are 2 inches, 2 inches, and then the larger one over here is about 2.8 inches. In addition, the height of the pyramid is 5 inches. Since it's a right triangle, the two legs are 2 and 2. The side of length 2.8 is the hypotenuse, approximately. So let's first start by finding the area of the base. It's a triangle, so 1/2 base times height, which will be 1/2 2 times 2, which gives me 2 square inches. So now let's use the pyramid formula. Volume is 1/3 times the area of the base times the height. We know the area of the base is 2, and the height is 5. So when we work this out, we get 10/3 cubic inches, or approximately 3.33 cubic inches. So the volume of the triangular pyramid is 10/3 cubic inches, or about 3.33 cubic inches. This is a nice example of the 1/3 relationship. If we had a prism with the same base area of 2 square inches and the same height of 5 inches, its volume would be 10 cubic inches. The pyramid is 1/3 of that, 10/3 cubic inches. Next, let's look at a cone. We have a cone with a radius of 5 inches whose slant height is 13 inches. We still need to find the volume, which is going to be 1/3 area of the base times the height. So let's start with the area of the base. For a circle, we would have pi times r squared. So 5 squared times pi. Using 3.14 as pi, we get 78.5 square inches for the base. But now we need to consider the height. We need the vertical height of the cone, not the slant height. And right now we have the slant height. But what we really want is the height of this right here. If I look at that radius along the bottom, that actual height and then our slant height, we know that this is 5 and this is 13. We can use the Pythagorean theorem to say 5 squared plus our missing side squared is 13 squared. And when we do, we get our side to be 12. 5, 12, 13 is also a common Pythagorean triple, so we might be able to memorize that and know that. But if we don't, that's okay. We would need to use our Pythagorean theorem. So our actual height here is 12. So our volume will be 1/3 times the area of the base times this height. And when we work this out, we get 314 cubic inches. So the volume of this particular cone is 314 cubic inches. This problem has several steps, but it's a great example of how geometry ideas connect. You are doing excellent work if you followed this all the way through. Multi-step problems like this take patience, and patience is a good part of mathematical thinking. In the next video, we will bring all of these volume ideas together and compare the formulas.